friends. Welcome to Infinite Acres. I'm sure you're going to love it here. And you know, we're very particular about our tenants, but I think you are going to fit in perfectly. Now, I picked out this apartment for you, and I think you'll find it's just your size. You know, this is our way of trying to solve to infinity. And the design is so simple. Why, we just took the curve y equals 10 over x from 1 to infinity and revolved it 90 degrees down to the ground. We have an apartment to fit anyone.
Well, we love the inside, but why did you ever paint the outside that horrible purple? It would look so much prettier in pink.
What a coincidence. You know, all our tenants have said that they prefer pink. As a matter of fact, I was just about to call a paint contractor. Let me take care of that right now.
Yes, uh-huh. $10,000 will be fine. I'll get a crew of men out there right now. Paintpot! Get a crew of men out to that Infinite Acres place right away and get that purple apartment house painted pink.
Infinite Acres? What's that, boss?
Oh, you know. It's that apartment house they built by taking the curve y equals 10 over x from 1 to infinity and then revolving it down to the ground.
To infinity? How can you paint something that goes out to infinity?
What kind of a dumbbell are you, Paintpot? Ain't you never heard of a limit?
Sure, boss, but...
But nothing. Oh, I suppose I'll just have to show you how I figured it out. Well, we'll start by looking at a single apartment. What is its volume? With a quarter of a cylinder, we can get pretty close to it. I suspect that even a dope like you knows that the volume of a cylinder is pi times the square of the radius times the height. Okay. The radius is y, the height's delta x, and we only want a quarter of it. So we get pi over 4, y squared, delta x. To approximate the whole volume, we do the same thing for each apartment, and we add them all up. Then we let delta x get smaller and smaller, and the number of quarter cylinders increase. See? Each quarter cylinder gets closer and closer to the actual volume as delta x gets small, in such a way that the sum gets close to the volume of the apartment house. Then we take the limit of this sum as delta x goes to 0, and we get what you call the integral from 1 to infinity of pi over 4, y squared, dx. Of course, what this means is the limit of the integral from 1 to, say, t, as t goes to infinity. Well, we plug in 10 over x for y, and, oh yeah, the constant pi over 4 slides by the integral sign, and we get 25 pi times the integral from 1 to t of dx over x squared. Well, that's the same as 25 pi times minus 1 over x from 1 to t. And that's 25 pi times 1 minus 1 over t. Well, we want the entire volume. So we take the limit as t goes to infinity, and that gets us 25 pi cubic feet. And that's about, well, 588 gallons of paint.
Gee, that's a beautiful derivation of the volume, boss. But what about the surface area? I mean, we paint surface, don't we?
What kind of a dope are you? Don't bother me with surface area. I just showed you we could fill up the whole place with 588 gallons. Why, we could paint it 10 times over with just a fraction of that. Those soft touches at Infinite Acres are paying me $10,000 for the job. I'll make a mint. Send some men out to that place and get that job done now.
Got it. Boss. Your figuring was right, boss, but you figured out the wrong thing. Let's get out there quick before we go broke.
go bankrupt. What happened? But there was nothing wrong with my mathematics. How could this happen?
You figured the volume correctly, boss, but like I tried to tell you before, it's surface that we paint. Oh, let me show you. Okay, I'll start in the same way you did by looking at one of the apartments. Now, what is its surface area? Well, let's look at what you get by revolving it through 360 degrees. Now, this surface area is approximately 2 pi times the radius times the length delta s. Well, the radius is y, and by the Pythagorean theorem, it's easy to remember that since delta s squared equals delta x squared plus delta y squared, then delta s is equal to the square root of 1 plus delta y over delta x squared times delta x. Okay, now I said the total area was about 2 pi y delta s, so that's the same as this. We only want a quarter of it, and this is what we get. Now, to approximate the total area, we do the same thing for each apartment, and we add up all the areas. Then we let delta x get smaller and smaller, and the number of sections gets larger and larger. Then, taking the limit of this sum as delta x goes by square root of 1 plus dy dx squared dx. And as you pointed out, boss, this means the limit as t goes to infinity of the integral from 1 to t.
What a mess! Do you really think you're going to be able to figure that out?
Okay, boss, maybe I can't figure it out, but I know it's enormous. Now, let me show you why. First of all, this square root is bigger than 1. And we can multiply each side by pi over 2 times y. So finally, the integral of the left side is bigger than the integral of the right. And figuring that out, let's see, y equals 10 over x, and the integral of dx over x is log x, so we get 5 pi log x from 1 to t, which is 5 pi log t. And the surface area is even bigger than what you get by letting t go further and further out, and that makes it infinite. You see, boss, when you were figuring the volume, you got the integral from 1 to t of pi over 4 times 10 over x squared dx, which was equal to 25 pi 1 minus 1 over t, which gets closer and closer to 25 pi as t gets big. But I got the integral from 1 to t of pi over 2 times 10 over x dx, which, as I just showed you, boss, is the same as 5 pi log t, and that just gets bigger and bigger as t increases. See?
Yeah, I see. I see 10,000 bucks flying out the window. But I still don't get it, Paint Pot. How come you can fill it up with paint and still not paint it?
Say, come to think of it, boss, I'm not so sure that you could fill it up with paint. After all, how thin can paint get?